So let's solve this question. Which of the following matrices has an inverse actually? Okay, so first of all, for the matrix to have an inverse, ultimately it has to be a non-singular matrix, right? So let's start. For a matrix A to be non-singular, to be or to have an inverse, let's say to have an inverse, to have an inverse, det A should not be equal to 0, correct? So basically determinant of that matrix should not be equal to 0. Now let us consider different matrices that you have. So the first matrix that you have is 1 4 8 0 4 2 0.5 2 4. So let's do this. 1 4 8, then after 0 4 2 0 4 2, of course 0.5 2 4 0.5 2 4 actually here. Okay, so in this matrix you can see if you have this first row, of course, and this third row is half times of the first row, or basically first row is 2 times of the second row. So since R1 is equal to 2 times of R3, therefore det of the matrix is equal to determinant, or you can say determinant is 0. Determinant is 0 because 2 rows are proportional. Okay, so if 2 rows or 2 columns are proportional, then ultimately determinant of the matrix is 0. So here the first row and the third row are proportional to each other. First row is twice the third row. Now coming to B, let's see. So in case of B, 1 2 3 2 4 6, 1 2 3 2 4 6, of course 3 2 9, 3 2 9 here. Okay, so 3 2 9. So in this case you can see, in this case basically if you check the first column and the third column is twice the first column. Okay, so C3 is equal to 2 times of C1, therefore determinant is 0 here also, correct? So determinant is 0 here also here. Then let's go to the third case. So case 3, let's see. 1 4 8 0 4 2, 1 4 8 0 4 2, of course 0 4 2, 1 2 4, 1 2 4, of course here. Okay, so this is what we have. So here you cannot directly say much similarities, but you can understand one thing. In this case, if you calculate determinant, so determinant is equal to now 1 times of 16 minus 4, 12, minus 4 times of 0 minus 2 plus 8 times of 0 minus 4. So this is minus 4. So this value, if you check, 12 plus 8, 20, 20 minus 32 is minus 12, which is not equal to 0. Okay, then coming to option D, let's say option D here, 1 4 8 0 4 2, of course. Okay, so 0 4 2, 3 12 24, 3 12 24, 3 12 24 actually here in this case. Okay, and here also you can observe one thing. Even here, this first row and third row, if you check, 3 1s are 3, 1 3s are 3, 4 3s are 12, 8 3s are 24. So here also R3 is equal to 3 times of R1. This implies determinant is 0. So out of these 4 matrices, only this is the matrix which has non-zero determinant. So ultimately only that's the matrix which has a inverse ultimately. Okay, the rest 3 determinants are zeros. So C is the matrix which don't have a 0 determinant, and that means it has an inverse. So therefore you can see, since this is non-zero, therefore this matrix has an inverse. Matrix has an inverse, of course. Okay, so this matrix has got a inverse. So this is the basically answer for this question. Option C is the correct answer. Thank you.